You ever get that feeling that your computer just doesn't get you? You search for something and you get back pages with the right words, sure, but the computer doesn't really understand what you mean. Well, what if we could actually teach the web to understand? That's the story we're getting into today. The long, fascinating quest to build a much smarter web. All right, so let's break down the real problem here. The web we have now is absolutely brilliant at connecting documents for us humans to read. But for the computers that are actually running the show, they don't really get the context. To them, it's all just characters and code, not actual concepts. And that puts a hard limit on what our software can really do for us, from a simple search to really complex analysis. The solution, believe it or not, really comes down to this one word: semantic. It's all about meaning. If we want to build a smarter web, we need to inject meaning and context into our data. We have to teach machines not just to read the information, but to actually process and understand it. Now, you'd be forgiven for thinking this story kicks off in Silicon Valley, maybe in a garage somewhere, but it doesn't. We have to go way, way back, thousands of years, to ancient Greece. The very first piece of our puzzle is this ancient quest to describe the world, to build models that make a messy reality just a little bit easier to grasp. And this brings us straight to a huge debate between two absolute giants of philosophy. You had Plato, who believed our models are just shadows of these perfect universal ideas that exist somewhere else. But then his student, Aristotle, came along and said, no, no, no. Models have to be built from the ground up by carefully looking at the world around us. This argument was the very beginning of ontology, which is just a fancy term for the study of existence, and it gave us the first real tools for classifying things. And this is so important because for a computer to understand the world, it needs a map, a model to work from. So what's really cool is how they started to visualize these ideas. A philosopher named Porphyry took what Aristotle was doing and organized it into this tree. It's so simple, but it's powerful. You see how it starts at the top with the most general idea possible, substance, and then it just branches down. Is it physical or not? Is it alive or not? It gets more and more specific with each step until you finally land on an individual, like Socrates. This was one of the very first attempts to map out how concepts relate to each other. And believe me, this idea of a hierarchy is still absolutely fundamental to computer science today. Okay, so we've got a way to model the world. That's one piece down. But how do we reason about that model? That brings us to our second big quest, the incredible ambition to take something as human as logical reasoning and turn it into a formal system of rules, something a machine could one day follow. And here he is again, Aristotle. He figured out that a logical argument has a structure, a kind of template that works no matter what you're talking about. Look at this classic syllogism. If premise 1 is true and premise 2 is true, then the conclusion has to be true. The logic is guaranteed. He was basically taking the process of thinking out of our heads and putting it down on paper as a set of rules. Now, this idea took a long, long time to develop. I mean, we're talking about 2,000 years. But over that time, thinkers like George Boole, and yep, that's the same Boole from the Boolean logic that powers every computer on the planet, and Gottlob Frege just kept refining it. They eventually created a formal calculus for logic. They literally turned reasoning into math, and in the process, they built the very foundations for computer science and AI. So let's recap. We have models of the world, and we have a formal way to reason about them. What's missing? A network. We need a way to connect it all together. And for that, we jump forward to the 20th century and the race to build a global information superhighway. And the speed of innovation here is just staggering. In 1969, ARPANET goes online. It had 4 computers. 4! Just a little over 2 decades later, Tim Berners-Lee invents HTML and the web browser, and suddenly we have the World Wide Web, a way for anyone to share and link documents with anyone else on the planet. Okay, this is the moment. This is the climax of the whole story. This is where these 3 completely separate threads, from ancient philosophy to formal logic to modern networking, finally come together. So just think about it. On one track, for centuries, we had these ways to build models of our world, going all the way back to our friends Plato and Aristotle. On a totally separate track, we had developed these incredibly powerful systems of reasoning, turning logic into something as predictable as math. And then, in a completely different universe, it seems, we built this revolutionary global network for sharing documents. But here's the crucial point. These 3 amazing, powerful ideas, modeling, reasoning, and networking, they all existed, but they were running in parallel. They never really talked to each other. Until now.
And this is where the vision of the semantic web was born, and it came from the inventor of the web himself, Tim Berners-Lee. The idea was to finally, deliberately, weave those three threads together, to build an extension of the web where information has explicit meaning baked right in, making it truly understandable to our machines.
So, what does a smarter web actually look like in practice? Well, we often call it the web of data, and it really is a fundamental shift in how we think about information online. The main goal is to go from data that's just machine readable, like the text in an HTML file, to data that is machine processable, where a computer actually gets it. And this is all built on a set of key standards. You can think of them as building blocks. There's RDF, which is like a basic sentence structure for data. Then there's OWL, which lets us build those complex models and hierarchies, those trees of porphyry, for any topic you can imagine. And finally, Sparkle, which is a query language that lets us ask really complex questions across all this connected data. Now, a really core idea here is something called linked data, and it's simpler than it sounds. Imagine you're on a web page about the Eiffel Tower. Right now, to a computer, Eiffel Tower is just text. But with linked data, that text becomes a unique web address. And when a computer follows that address, it doesn't get a web page for a human. It gets raw structured data. Is a tower, located in Paris, height 330 meters. It's a web made for machines. And this quote is so important because it gets to the heart of it. The semantic web isn't some brand new Web 3.0 that's going to replace what we have. Not at all. It's an evolution. It's a set of ingredients and standards that are slowly making the web we already use way, way more intelligent. So I just want to leave you with this one final thought. What if the entire web, everything, from Wikipedia articles to government statistics to product catalogs, what if it all behaves like one single, giant, connected database? What new questions could we ask? What huge problems could we solve if the web wasn't just a library of documents, but became a single global intelligent database?